code with RxJS. I'm your host, as always, Matthew Podwysocki, aka Bluer Than Blue Falcon, aka Lambda Calrissian. So let's go ahead and get started today by going through where we've been with RxJS. So if you haven't seen any of these broadcasts till now, you've got plenty to catch up on, starting with creating an observable to sequences over time, to creating your own observables, converting events to observables, doing the basic composition, piping operators, and so on and so forth. So there's a lot to get caught up on, but luckily all of this code and examples are here for you, so you can go ahead and get started on what works best for you in terms of your learning style. So yesterday we talked a lot about skip and take and those sorts of things. So today I wanted to talk about error handling. So that's a kind of a really large topic, as it were, especially when you think about the observable contract. You think about error handling at the very core of what an observable is, because the observer itself has a contract for error handling. So let's go, instead of looking at my things here, let's go in and take a look at, and let's play around with some code here. So as you can see, I've got a lot of things here, and I'm going to comment out for right now, just so that we can go and get started here. So let's go there, close that off, and all right, cool. So we've got a blank slate here that we can deal with, I believe. So let's go ahead and get started. So think of your normal observable sequence. So we could say const num is equal to of 1, 2, 3, and then we can subscribe to that later, saying num dot subscribe. And what you see here is a partial observer. And what exactly is a partial observer is something that allows us to specify a next handler, an error handler, and so forth. So if I say next, all right, so next gives us the item or the number. So item, whatever, and say console.log item. And on an error, let's just say, okay, whenever we get an error, we'll console.log and just say error, and whatever the error happens to be, error.message. We'll just go and clean that up. Cool. So when we run, of course, we're never going to get, and don't forget to complete, because, well, complete is telling us when our sequence is done. All right. So now we can say npx ts node of 21 index.ts. Okay. Cool. 1, 2, 3, and done. Now the problem is that we could create our own observable here, and let's do that. And let's go and say new observable. And people wonder why I get pull requests for spelling. Well, I'm still not used to the butterfly keyboard on the Mac, to be honest. All right, so here we can say next server.next 42. And what that'll do is, when running that back, will give us 42 and done. But what happens when an error happens? So there's a number of things. So for example, errors just naturally happen. Now if we say observer.error and say new error, whoops. Okay. What happens exactly? Well, what happens is that it gets thrown onto the error channel automatically. And since we're subscribing to the error channel down here as part of the chain, then we have the goodness of being able to gracefully terminate our sequence instead of letting bad things happen. But let's just, for the sake of argument's sake, let's not actually catch the error at all and see what happens. So if we say npx ts node, and boom, bad things happen, as you can see here. You'll see that we do in fact throw an error, and it says, okay, well, at subscribe we actually physically blew up, and we give you a nice inscrutable little stack trace to look through as to what caused your error, but ultimately came down to the fact that we were saying observer on error, whoops. Now the same really applies to if I just said throw new error, whoops, what happens? And it's the same thing. So whatever happens here, but if I bring this back, and then it should be trapped, and it does. All right, so this is very much unlike a promise. So with a promise, you can reject a promise, and if you don't handle the catch or the then something happens in terms of it getting thrown onto the process of the unhandled rejection. So if we say const p equals new promise, and we'll give it a number, and we'll say res, reg. All right, and then we can say reject new error, whoops, not rejects, reg. Okay, go, okay. Why are you expecting that? Okay. All right, anyways, let me close this out. Okay, and okay, which is the same thing as doing promise.reject, but whatever. And now if we say p.then and say console.log, what happens? Node should at least tell us that there are unhandled promises. Yes, indeed, they are. And so it's saying that there is an unhandled rejection here, so that we were not handling with a catch. So currently it doesn't crash, it doesn't crash Node, and it doesn't crash your browser, but ultimately it might in the near future, at least, that are not handled somehow will cause the Node.js core thing to crash. Otherwise, you would have to catch the process unhandled rejection yourself. But just kind of know that observables, looking at that, will cause your code to crash if you're not careful. So cool. So anyways, let's go to back to our little presentation here and talk about what we're talking about today, which is error handling. So error handling, we've got a lot of good things. So speaking back philosophically here, we're dealing with collections, and when you're dealing with collections, you want to support a try-catch mechanism to say, to iterate through a collection, handling each item, and then finally handling the complete once the iteration is complete. otherwise handle the error when it happens. And so Rx, being a push-based collection, flips it on its head, where instead of iterating over this, it's pushing the values to us. But it's largely the same kind of logic here, as if you understand for this for of handle next and then handle complete, or handle error, it kind of makes sense as to how Rx operates. The try catch isn't inside of here; it's outside of the iteration. So any error causes the looping to terminate. It's not like you can go in here and catch and say just go to the next item. It doesn't work that way. So anyways, we showed you kind of how the things where bad things can happen. Where, like for example, in your map or any of your calls to AJAX services, whatever it is, fails. And what it comes back with, it could come back with a 500 error, which you translate back to an error some way, somehow. Then you're going to want to deal with it some way, somehow. And so that's it's a really fundamental piece to understand, is because when you're starting to do anything that's not animation based or anything like that, errors can happen. Just as well, if you want to take your, for example, your flat map or your merge map or your switch map call, and you want to translate something that's comes back with a 400 or 500 to an exception, you can create an observable for that particular piece with throw error. So it used to be called throw, and then we changed to the whole pipeable operators, where we can't really export keywords, language keywords such as throw, if, those kinds of things. So we've had to rename we've had to rename a good number of those operators coming through there. So that's when you start to deal with throwing errors, is that you can throw errors like translating something during a merge map operation or flat map operation, and then call throw error from there. Now, to deal with catching an error is pretty straightforward in terms of, if we know that we can throw an error, then we can certainly catch an error. And it's not really all that much different than promises in the fact that we have a catch error method here. Now, how it differs is that from a promise could absolutely do nothing, and you just have an empty catch block. What we require with observables in Rx is that we require you to return an observable back to us. So it could be any number of things. Like, for example, if you get a thing saying your server's down, well, you can certainly do a number of things, but you can also return empty. You could return some cache data, whatever you want to do. Those are perfectly acceptable answers in terms of what you need to replace what would have been in the stream with something else. So when you call catch error here, in this particular case here, it will run halfway through. So we can, let's take this example and run this through in our code. So let's switch back to our code, and let's run this through. All right, so let's run this through and show you that good things or bad things can happen. So what happens here is that we have 1, 2, and 3, and then merge map. So our merge map will say, okay, if the item is greater than 2, throw an error, whoops, otherwise return item times item. And so we do that for the first 2 here, and then we have this error. So catch error in here takes in the error that we got from what was ever thrown. So it was either through physically throwing an error yourself or calling throw error. Either are acceptable. Then here, I was just doing some logging just so that you kind of understand where the code is and that sort of thing. So just so you understand where we're going is that error caught and then saying, all right, 42 is the answer here. So cool. That's really how to handle catch in such a way that you get the error and then you continue on with the next sequence. There used to be overloads where we would you could supply a whole list of observables to catch an error with, and then the next one that doesn't error happens to be the one you replace it with. We've done away with that in favor of just the simple catch handler because, well, it's easy enough to do. But we still have some quirks in the library. I'll be the first to admit that, where we will have some pretty old operators in there. Not to say that they're not useful, but they're interesting. So we have this on-air resume next, and for the VB people out there will appreciate this, is the idea of on-air resume next. Now, it's not quite exactly like that if you're going through and iterating through a for loop on there. It's a little bit different in that what it'll do is it'll replace whatever the errored one is with our next piece, and then continue on with any other observables that we happen to give it. So it accepts a good number of these values. And if we take a look at on-air resume next, I don't imagine there would be much data here in terms of why you would use it or how you would use it, but there is. So it can be considered a concat operator with error handling, and that's absolutely true. It can. So it will continue, it will swallow the error from the previous one, and it will continue with the next sequence. So we can run through this particular example here, switching back to our code, and let's run this through. All right, so I don't need that. Cool. All right, so we have now, walking through this code, we're going to have the first sequence is going to error out. Then the second sequence, that's also going to error out. Then the third sequence is going to return us a value, as is the fourth sequence. So we can take all of these sequences, and let's add num4 to this one, and then run this through and see what happens. What happens is that these first two are dropped because they're both errored sequences. If they had done halfway through, quarter way through, whatever, then their output would be given to us, and then it would switch over to the next one, and then switch over to the next one. So it would keep on going happily on its way with any number of these observables that you give the sequence that you're merging together. So that's really kind of a cool thing, is if you're really into, I don't care if any of these succeed or not, just keep on throwing them in there. Well, then on-air resume next is probably something you're going to want to spend some time on. Now, finalizing an operation. So we've already covered try and catch when we talked about the basic iteration here. We have built in, like I said, with try and catch, naturally as part of our thing in terms of both in the subscribe itself as well as catch error, to allow us to substitute something for our particular value, the error that we happen to get. So there are kind of two things that we can do. Is we can have a catch which replaces the value, or catch at the very end with a subscribe. either is valid. But finally is a different story altogether, because finally has to wait for the entire chain to finish before we can do them. And we have that through what we now call the finalize operator. So we used to call it finally, but once again, because of the language constructs of JavaScript and not being able to export something named finally, then we had to switch to something else. But that's okay. I mean, it's not a huge deal in terms of if people can understand. Finally, they can understand finalize. It's not a huge leap from one to the other piece. But let's walk through that code sample here. And it can get a little complicated, or so let's just walk through this little by little in our code window here. Cool. So let's get rid of that. All right, so the first example we're going to have is just a simple example of a single value, and then the single value is going to finalize by saying finally called. Now, what you see on my subscribe handler is I have next, error, and complete. So I'm going to show you exactly when those particular things happen. Conversely, I'm going to have one that has throw error and see when those particular things happen. So let's run this example here and we'll go through what the results mean. All right, so what happened here is for the first example, we get next of 42 and then done. So by the time that these two things are done, finalize is then called afterwards. So this is great if, like I said, is if you're doing something where something absolutely needs to be cleaned up, which is what you would use a finally for anyways, whether it's any sort of I/O that you need to do, any sort of side effect when the entire chain closes, that you can do in the finally area. So regardless of whether an error happened or not, you can ensure that something is cleaned up, regardless of whether an error or complete happened. But if you had something in say your teardown phase and so forth, those are automatically going to get called as part of the whole teardown sequence. It's something above and beyond that's not in your control that you might want to call finally on, for example, because like I said, is like if you had add event listener and remove event listener, if an error happens and you catch it, then it still does the teardown logic for you. Just as if it completes, if you said take one and complete the sequence, it will also do the teardown language. So something above and beyond that sort of thing is what you would use finally for. But it's very helpful once you understand what it's used for and why. All right, so next we have retrying an operation. So we have a number of ways of retrying an operation, but the first one and the easiest one is just called retry. So in the cases where you're making any HTTP calls or network calls, whatever calls you happen to be make over the wire, things could fail for whatever reason. Even on the disk, things can fail, race conditions or otherwise. So with that, we want to give you a way to do that via a number of ways. And the first way that we'll do that is with the retry operator. So the retry operator will try infinitely if you don't specify. So the count here is -1, so it won't go any further down. But you can think of the number is actually tries. So if you said try it 3 times and it doesn't work, then it fails. Whereas you would say where you would say retry 3 times, meaning the first one failed and then retry it 3 times. Well, the number that we have there is kind of a misnomer in that respect, in that it really just means the number of tries that you want to do before you give up. So it's ambiguous language, and it's caught a few people off guard, but it is what it is. It's something that we're stuck with legacy-wise. But retrying an operation, like I said, is fairly trivial in terms of being able to retry after X number of calls. So let's take this code that we had in our little example and put that in here. All right, so what we're going to do is we're going to create an observable here, and if the retry count here is let me fix that typo there. All right, so if the retry count is greater than 2, then is equal to 2, which means I'm going to retry a number of times, and then 42, and then complete. And then what we can do is then we can say down here, pipe to retry of 3. Now when you do that, we'll see that next of 42 happens. So we could put in here a number of times that it failed if you want to do some like console log. Just said failed. Cool. All right, and then we do that. And what you'll see here is we have 1 failed call. Now if we set this to 3 and set this to 4, in terms of the number, sheer number of failures that we want to deal with, we'll see that it fails twice, and then it finally gets to the time that it is successful. However, if we were to say only do retry 2 times, then bad things will happen along the way, or apparently it doesn't. Let me retry 1 time. Maybe we did fix that bug. I don't know. There we go. Okay, so it failed twice. So actually, we did fix the language around that. Okay, thank God. All right, consider me an idiot, and consider everything that I just said previously to that null and void. It's now the number of retries after the failure. Cool, good to know. All right, so let's move on to another kind of retry that we can do. And this one is a very cool one because it gives us a lot of control as to what we can do. And it's called retry when. And it's fairly difficult to kind of understand how it's being used. So there are some good blog posts out there on how to use retry when. But let's just look at the signature here. This actual thing came here from the RxJava community. And what it does is it gives you an observable with the exception as an error. So this will emit the throwable that caused the error to return from the. There's a lot of gobbledygook in here. So what you really need to understand is the following, is the fact that you can take this particular errors and you can pipe it to something else, sort of like delay when. So if I wanted to delay the call, for 500 milliseconds, I could do so. And in fact, let's try to code that real quickly here. So instead of just saying, all right, so const num is equal to obs.pipe, and let's do retry when. Okay, retry when. And let's get the errors coming in, and what we can do with that is that we can say return errors dot pipe Okay, delay when, and it'll give us a duration selector. We can do whatever we want to, but I'll just say here 5,000. Let's give it a observable never, or we can just give this a timer. Let's give it a timer. Timer of 5 seconds, something like that. Actually, let's give it a second. So what we can do here is we can now say, no matter what happens, delay the next time by a second before you do it again. So here, it's going to get a number of failed calls and then finally get to 42. But that's certainly interesting. But we could do more of an incremental back off if you want to. It gets a little interesting to do that, but why don't we humor ourselves and actually try this? All right, so what we need to do is the following, is we need to say, instead of errors pipe, we need to look at our code that we already have, which is set here. And what I'm going to do is I'm going to be fairly clever about that in the fact that I'm going to zip together errors, so our errors. So let's go back to our code. All right, going back to our code, we will say return zip. Okay, and let's do errors and range 1 through 3. Cool. So what we're going to do is we're going to say 1 through 3. It could be 1 through 10. It could be whatever we want to make it. So we've got that now. So now that we've got a range put together with our errors, now what we can do is we can get only the, say, the index from it here. So let's do that. So to do that, we will destructure our call, and so index, and return our index. So then, if I can type correctly, I'd be a genius. Okay, and index. All right, cool. Any is not assignable to, cool. Errors is that, and we'll just call this number right now because it just can't seem to. All right, hold on. How come this worked? Of any is. All right, hold on. Let's just copy in my code here because somehow I made this work yesterday. So let's just do that. Copy back, and there we are. Okay. So what we're going to do is we're going to take the errors here, which is observable of any, and then our range, which is our count of 1 to 3. And then we can tap along the way and saying we're going to retry after X number of seconds, just in case you want to give a message back to somebody. You can do that. And then we'll say delay when, and then whatever the timer happens to be, 1 through 3 seconds, we can delay it then. So running through that here, we should get a number of failed calls. So we're going to retry after 1 second and retry after 2 seconds. But like I said, is we could keep on going and going and going just as long as this keeps failing, and go on from there. So that's really what I wanted to cover today in terms of basic error handling. But what I want to get to at some point is really sophisticated error handling that we can probably do at some point implementing ourselves. There's a Java library called Failsafe, and it's a really, really cool library that you can play around with and get some ideas as to some of the power of dealing with error handling, because there are a lot of different ways about doing this with jitters and various retry logic, whether it's variable or not variable in terms of its handling. So it's really, really cool in terms of what's the art of the possible when it comes to error handling. What we can do, all right, so what would cause, all right, so I usually unit test state streams. There's a question in here. State streams and such by converting to a promise via for each or to promise. Would that cause any weird handlers compared to using subscribe error handler? I don't think it should necessarily be an issue, but subscribe error just basically is your basic handler. But if you want to use to promise and do that, that's fine. So you're hoping for an incremental backoff. So yeah, incremental backoff. That you can do, like I said, through our handy dandy little retry when operator, and we could probably give ourselves that in the future. We could probably write one and maybe get it sent to core. So it is possible that we could probably do that. And like I said, is we can get something like failsafe, I think, at some point with Rx, and not only Rx but also IX as well. I think both are reasonable that we could do. So really, it's up to you in terms of where we go in this series, but I really wanted to get you a flavor of kind of some of the error handling that we can do. Now, what I didn't cover are things like timeouts and so forth, and we can cover some of that in a time-based one a little bit later. But if the zip example is good enough for you, I mean, it's in the documentation, that works too. But if we want to make it something easier, like I said, is you don't have to use zip and map and all those other crazy things, well, then we can figure it out together. So anyways, so thank you all very much for coming today. I really appreciated the feedback and everything else from you all. Really have appreciated all the feedback that I've been getting, and it's helping me create some better content for you all. So up next, we'll start to dive into to deeper and more interesting subjects as well. And like I said, there's a lot to cover with this particular library here. So do stay tuned. Follow me on Twitter at Matt Podwysocki, MattPodwysocki, and follow me here on Twitch, Bluer Than Blue Falcon, and follow me as well on YouTube. So thank you all very much, and I will see you next time. Bye-bye.